NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will add and subtract common logarithms written in bar notation, step by step, just like you would do with a log table. We'll also correct a common mistake people make with co-logarithms. Example, for the first problem, we are given log x equals bar 2.8512 and log y equals bar 5.9320. Find log x plus log y. Before we compute, remember how to read bar notation. Bar c dot m means negative c plus 0 dot m. So bar 2.8512 is negative 2 plus 0.8512. We'll separate characteristic and mantissa to add cleanly. Let's decompose both logs. Now add. Start by grouping characteristics and mantissas. Add the mantissas. 0.8512 plus 0.9320 equals 1.7832. Add the characteristic. 0 equals 1.7832. Add the characteristics. Negative 2 plus negative 5 equals negative 7. Because the mantissa is greater than 1, carry 1 to the characteristic. Negative 7 plus 1 equals negative 6. Mantissa becomes 0.7832. Convert back to bar notation. Bar 6.7832. Now, the subtraction problem. Example, we are given log x equals bar 4.6392, log y equals bar 2.1860. Find log x minus log y. We will show two correct ways, direct subtraction and the co-logarithm method. Both must give the same result. Method A. Decompose each. Subtract the mantissas. 0.6392 minus 0.1860 equals 0.4532. Subtract the characteristics. Negative 4 minus negative 2 equals negative 2. Combine. Negative 2 plus 0.4532 equals negative 1.5468. Write this in bar notation as bar 2.4532. Method B. Using the co-logarithm. By definition, co-log of y is negative log y. Since log y equals bar 2.1860, which is negative 2 plus 0.1860, the negative of that is 1860, which is negative 2 plus 0.1860. The negative of that is 2 minus 0.1860, which equals 1. In this lesson, we will multiply a number by a logarithm using two examples. We will handle a positive multiplier first, and then a negative multiplier using the idea of the cologarithm. Case 1. If the multiplier m is positive, we simply multiply, remembering that the mantissa must remain positive. Here is the example. Log of x equals bar 2.8140. Find 5 times log of x. First, interpret the bar notation. Bar 2.8140 means negative 2 plus 0.8140. Now, distribute the 5. 5 times negative 2 plus 5 times 0.8140. That becomes negative 10 plus 4.07. Combine to get negative 5.93. Finally, write it in standard log form with a negative characteristic and a positive mantissa. Negative 6 plus 0.07, which we write as bar 6.07. Visually, negative 5.93 sits between negative 6 and negative 5. Shifting one more unit left to negative 6 leaves a positive mantissa of 0.07. Case 2. If the multiplier m is negative, we multiply the cologarithm of x by the absolute value of m. The cologarithm is negative log of x written as a negative characteristic plus a positive mantissa. Here is the example. Log of x equals 1.1243. Find negative 5 times log of x. First find colog x, which equals negative log x. That is negative 1.1243. Write it as bar 2.8757. Now multiply by 5. 5 times bar 2.8757 equals 5 times negative 2 plus 0.8757. That becomes negative 10 plus 4.3785. Combine to get negative 5.6215. Finally, write it in standard log form as negative 6 plus 0.3785, which is bar 6.3785. Summary. When multiplying a logarithm by a positive number, multiply normally and keep the mantissa positive. When the multiplier is negative, switch to the cologarithm and multiply by the absolute value. Our answers are 5 log x equals bar 6.07 and negative 5 log x equals bar 6.3785. Division of a common logarithm by a number. We will master 4 cases using the classic characteristic and mantissa method, including bar notation for negative characteristics. Before the cases, a quick reminder about bar notation. A barred 1.2538 means negative 1 plus 0.2538. In other words, the bar is only on the characteristic, and the mantissa stays positive. The rule we use is simple. To divide a logarithm by k, divide the characteristic part by k and the mantissa part by k. Then rewrite the result so that the mantissa is between 0 and 1. If k is negative, compute the value and then express it with bar notation if needed. Case 1. Positive characteristic, positive divisor. Example, log x equals 2.1245. Compute log x divided by 3. Case 2. Negative characteristic, but divisible by the positive divisor. Example, log x equals bar 6.8141. Divide by 3. We divide the characteristic negative 6 by 3 to get negative 2, with a positive mantissa 2713 over 3 decimals rounded in tables. Case 3. Negative characteristic, not divisible by the positive divisor. Example, log x equals bar 2.1225. Divide by 5. The trick is to adjust the characteristic by adding and subtracting the smallest amount needed to make it divisible by 5, while keeping the mantissa positive. Case 4. Division by a negative number. Example, log x equals 2.2386. Compute log x divided by negative 3. Do the arithmetic, then express the final value with bar notation, so the mantissa is positive. A final visual reminder. Think of a logarithm value as the sum of a characteristic, the integer part, and a mantissa, the fractional part between 0 and 1. Bar notation places the bar only on the characteristic while keeping the mantissa positive. Recap. Case 1 positive characteristic, divide directly. Case 2 negative characteristic, divisible by the divisor, divide and keep the mantissa positive. Case 3 not divisible, adjust the characteristic to the nearest multiple of the divisor and compensate on the mantissa, then divide. Case 4 negative divisor, compute and write the final value in bar notation. Practice a few more to make the steps automatic. Final numerical results for our examples. 0.70816, bar 2.2713, bar 1.6245, and bar 1.2538. Welcome! In this walkthrough, we will follow a structured algorithm to multiply or transform logarithms, exactly as shown in the provided guide. First, we show the problem context as an example. Case 1, both logarithms positive. We are given log x equals 2.2345 and log y equals 3.0124. Since both are positive, we directly multiply, like ordinary decimals. The product is 6.7312. Case 2, both logarithms negative, shown using bar notation. We have log x equals bar 1.4123 and log y equals bar 4.2145. Convert each bar notation to its true decimal value, then multiply. Bar 1.4123 becomes negative 0.5877. Bar 4.2145 becomes negative 3.7855. Multiply to get 2.2247. Case 3, one positive and one negative. Let log x equal 2.2145 and log y equal bar 3.4122. Convert the negative logarithm from bar notation, then multiply. Bar 3.4122 equals negative 2.5878. Multiply 2.2145 times negative 2.5878 equals negative 5.7307, rounded to 4 decimals. Express this in bar notation. Negative 5.7307 equals bar 6.2693. Final problem. Transform a root using the power rule. Given log x equals 5.5130. Find log of 1 over the cube root of x. Rewrite as x to the power of negative 1/3. Then use the power rule. The result is negative 1/3 times log x, which equals negative 1.8377 approximately. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.